What is today's date?
19.
18.
18. I trust you guys.
Let me ask my
Okay, today is April 18th, 2011, and we are talking about polynomials. What makes a polynomial, what breaks a polynomial, what is known about them. There's a couple of general rules for the definition of polynomials, which I want to make sure you guys... Okay, the big things are polynomials. First off, they're functions, so that tells you a couple of things about them right away. They're always going to be written in the form y equals, and they always pass the vertical line test. There's a couple other things that will come in handy to know about them. In these functions, the coefficients, I'm sure I misspelled, are real numbers. The exponents are integers. Coefficients are real numbers. The exponents are integers.
Integers have to be real, right?
Yeah, integers have to be real. That takes care of it. And the form is always f of x equals a sub 1 x to the n plus a sub 2 x to the n minus 1 plus a sub 3 x to the n minus 2 plus dot dot dot. And if n starts off as an integer, and the a's are all the different coefficients and they're real numbers, if this starts out as an integer, each coefficient as you go down will be an integer, and you will have a polynomial. And once you're certain you have a polynomial, you can start making certain rules about them and you can answer questions quickly if you're sure you're looking at a polynomial. Okay? For example, can a polynomial have a fraction with an x on the bottom?
Yeah. No, yeah. Because of hyperbola.
That's not a polynomial.
But it's a function.
It is a function, yes.
Because at one point x will equal, can't x equal 0?
Well, the thing is, if it's of this form, there's no way to turn this form into any sort of fraction with an x on the bottom. So you can't have a vertical asymptote. Okay? You also can't have... Not allowed. You also can't have a root of an x in there. That also can't happen. When did we recently talk about square roots of x and x's in the bottom? In connection with what?
What we just did.
What we just did. What was it? What was it called? What about functions?
Vertex form of a parabola.
Before that.
No, parent functions.
Parent functions. What do we do?
I didn't take notes on that.
What were you looking at?
Domain.
Domain. Okay.
You can't have a square root of x. You can have a square root function.
Yes, but that's polynomials. Not all functions are polynomials. Polynomials are a subset of functions. Polynomials are only certain types of functions.
So not all functions are polynomials, but all polynomials are functions?
Very good. Yes.
It's like the rectangle square thing.
Yeah, it's like the rectangle square thing.
I still don't understand.
So with this one, okay, so forget about that for now. With this one, this can't happen. For one thing, this would mean we had x to the 1/2. And are we ever allowed to have a non-integer exponent in a polynomial?
False.
Yes, can't do that. We can have, this is a function. There's no problem with this as a function. We talked about this. But these were the things we talked about in connection with domain. Okay, so what this means is...
It can be x to the 1/2 though?
No, it can't be. It can't be. These are the same thing. Let me be very clear.
Yeah, I understand.
So what this means is the domain of a polynomial is always going to be negative infinity to infinity. Polynomials are what are called continuous. They don't have any breaks. They don't have any places where they don't exist because of the x value. Okay, the range can be different on a polynomial. The range doesn't have to be. Polynomials can be in factored form. I'm not going to go into much detail about this today, we'll get back to it. But polynomials, factored. For example, I can have f of x equals x minus a, x minus b, times x minus c. Now this doesn't look like this example over here. But if I give you in this form, in the form of binomial factors, where the x's are all to the first power, some of them can even be squared, where each of these is a polynomial. In other words, if I multiply polynomials together, this one would always multiply to, well, let's see, the first term would be x times x times x, right?
X cubed.
So that would be x cubed. I'll go ahead and skip a lot. There would be a lot of terms in the middle with some x squared and some x's, which we then combine. We'll skip those. They're not the important ones right now. And this one would always end, in this case, since it's minus.
Negative ABC.
Yeah, this would end with negative ABC.
ABC family.
Pardon?
Sorry.
Yeah.
That the rule that you gave us over there, it's not like an absolute rule because like you can one of those terms can be missing and they can be zero.
ABC family.
Yeah, there's no reason a can't be 0. A can be 0 and can cause them to be missing. Okay? So, we'll get into more detail on this, but for now I'm just telling you, this is a polynomial even if you see it in factored form. In fact, I'll go ahead and give you a couple of other rules like this. May I erase this part?
Yes.
Okay. I'm going to use p of x to mean polynomial. Okay? If I have one polynomial plus another polynomial, I will get a polynomial. If you add polynomials, you still get a polynomials. Okay? What do you think happens if I subtract two polynomials?
You also get.
You also get a polynomial, which means you have to have that domain. Pardon?
Get 0?
If they're the exact same polynomial, you get 0.
Negative 1.
Yeah. Now, what if I multiply a polynomial times a polynomial?
You also
Get
get
a
a
bigger
polynomial.
Well, it's still a polynomial. Poly just means many.
Oh, right.
I'm assuming you guys somewhat
That's
remember from
after
Algebra
4,
1.
It's after 4 though, isn't it? Or after 3? Like,
Well, it goes monomial, binomial,
yeah.
trinomial,
Sorry, I was getting
and
those
then really we
binomials.
just start saying polynomial.
Yeah, that's what I just
at
said.
that point.
That
After
P
3.
looks like a line of
It does. But it truly does,
no,
actually.
the one in the middle.
I hate all of your P's.
Yeah.
They're so ugly.
Alright, this is still,
I mean, I can never get them mixed up with a 9, but still.
okay, this is still a polynomial. Now, here's the big exception.
P and a 9?
If you divide a polynomial by a polynomial, you do not
Ever?
If you divide a polynomial by a constant term, like 5, you still have a polynomial.
Because you're dividing each term by 5, but this
Yeah.
I feel like you're crossing out stuff, so.
You know, if you put an x on the bottom, you no longer have a polynomial once you have an x down there. You have zeros to deal with, you have all sorts of problems. This gets a little complicated, but this definitely doesn't always give you a
Isn't
polynomial.
doing that like multiplying by the reciprocal of the bottom polynomial, which
Yep.
would put x under a fraction?
Yep. So that means it's not a polynomial in this case. So that's a great way to look at it. You get an x on the bottom, you don't have a polynomial, even though it may have some of these other qualities. So these are your basic rules. And again, I know this isn't Algebra 1, so I'm not defining monomial, binomial, trinomial, all that kind of stuff. Now for some rules you may or may not have seen before. We're going to introduce something that we're going to refer back to regularly in your lives for the next year and a half, throughout calculus as well. One of my actual, I'm such a dork, favorite calculus tests in the pre-graphing calculator days was the one where they would give you one massive polynomial to graph. It'd be the whole test for an hour. Just this one polynomial to graph. But you had to graph all the x-intercepts, the single y-intercept, because a function better not have more than one y-intercept. And you had to graph all of the minimums and maximums, like you guys learned how to find on a calculator last year. And you had to graph all of the points of inflection, where it switched from smiling to frowning, all without a calculator. So we're going to start teaching you some rules of how you do that, but you're not going to be done learning these rules for another year. Okay? So, but polynomials have these properties that let you do that. I just thought it was so cool. You can make the craziest 5th, 6th, 7th degree polynomial. Give me an hour and no calculator, just pencil in my brain, and you can graph everything. At that point, that was first semester college, which for me was 17. So that was...
You're younger than me.
You'll get there.
How are you 17 your first semester of college? Like,
We'll talk about that some other time if you want. But,
My-
well, we won't be, that's not what we're putting online though. Okay, so some of the homework tonight is just going to be what is a polynomial and what isn't. And I think I've given you enough rules to sort of think about it. Pardon?
That's kind of awesome.
Well, some of it. Now for the more interesting stuff.
Oh.
To me,
do we have any numbers to write down for homework?
not yet. Not yet. Okay, end behavior. Once you're certain something is a polynomial, it has some consistent behavior that can help you predict how to graph it. Remember, if it's not a polynomial, all this goes out the window, even if it is a function. Okay? But once you know it's a polynomial, some of its behavior is predictable. End behavior is my favorite. And we're also going to talk a little bit about limits here, again.
Do they
Alright.
always exist?
These limits will exist.
Always?
On a polynomial, yes.
No matter what?
Can't think of an exception. Really trying to, but I'm
Is
gonna.
this a rule about polynomials?
We're getting there, Ramsey. Slow down, cowboy. Okay, so end behavior. Now, if your polynomial starts off a sub 1 x to the n plus dot dot dot. Everything we're going to talk about right now is found entirely in the first term of the polynomial. Okay? And here we go. First off, n is greater than or equal to 1, and n is an integer. All right. Polynomials, you guys saw last year in Algebra 2, I hope, how polynomials can have some really interesting loops. If not, you can look up there at some of those shapes on the wall I have. Every quadratic is also a polynomial. Talk a little about where those loops come from, but the end behavior is very predictable. You guys get what this means. This is the first stage. Okay, I'm going to write some rules up here, then we're going to do some examples of it. If a sub 1, your leading coefficient, your very first number you see in the polynomial, is positive, and n is even. If your very first number you see is positive and n is even, then your polynomial at its end behavior will go up in both directions. I have no idea what it does in between. Maybe it's a parabola. Maybe it has 6 or 7 loops. Not loops, it can't be loops, but humps. Maybe it's like a dromedary, it'll have 2 humps.
Maybe it's infinite humps.
Infinite's hard to pull off, but it could be a very large number. But at its end, I realize it will go up. When you go, at some point, it will stop looping and continue going up to the right and continue going up to the left forever. There are a couple of different ways we can do this. Informally, we call this one a touchdown.
It's like,
You math people.
Touchdown!
You have a sense of humor.
I know, we're crazy that way. Actually, when I had a class 2 years ago where everyone was watching the TV show Heroes in the first season, I could get away with saying this was Yatta!
Ah!
Yeah, I know I'd have 1 or 2 of you in here. Yeah, hero. Now, the formal math way to write this is the limit
Does not
as
exist.
x approaches positive infinity of the function is positive infinity. Now, a limit is always what y is doing, what f of x is doing. A limit, when it's written this way, I should say, is what y is doing. So this means as x goes as far to the right as you can imagine, y goes as far up as you can imagine. This will test it. As x goes as far to the right as you can imagine, y goes as far up as you can imagine. The other part of this definition is as x goes as far to the left as you can imagine. The limit as x approaches negative infinity of y. As x goes as far to the left as you can imagine, y
Goes down.
Well, in this case, it also goes up,
Oh.
because this is a touchdown. Y goes up as high as you can imagine. This is the formal way to write what happens if n is even and a is positive on the first term of your polynomial, assuming you put them in order and you have the largest exponent first. Okay? In the n behavior will always be some sort of touchdown. We don't know, and for tonight don't really care what happens in between. This is the informal word. This is the formal, slightly more formal notation. Okay? Any questions on this one or how I've written it? Yes?
It says, as x goes as far to the left, then y goes as far upward.
Yep. That's this one up here. Yes?
Do we just graph the arms? Or
For tonight, yeah, or you just answer questions about the arms. We'll get to filling in the middle throughout this week. Yes, sir?
Do you have to remember all
Yes.
every single one that you're going to give us?
3 more.
That's not bad.
Alright, there's only 4 of these.
Wait, there's not a cool name for this one?
Yep, there's a cool name for each one of them, although
Oh,
one of the
cool.
names is not so cool.
I love mathematicians who have a sense of humor.
Excellent. Okay, same situation. It's a polynomial, so I could say p of x. It's again a sub 1 x to the n plus, I don't care for this example, all sorts of further x's and a's. In this case, n is still greater than or equal to 1 and an integer. And now, a sub 1 is greater than 0, so this number is positive, but now n is odd. N is odd.
Will it go like that?
Exactly, well, not exactly wrong. No. Actually,
not even.
no.
That's
I
not
kind of
funny.
wish
That's not
our viewing audience at home could see your interpretive dance, Jan, but this one is one we will call
Did it go down?
ballerina.
Oh,
It's very good, Ramsey.
Is that what we're going to be doing? Like,
Well, yeah, the I didn't say psychologically unhealthy ballerina.
did you see
Um,
it? It was so good.
I did. The only
I rented it on Apple TV.
It's on demand.
it's very good. The only problem with this test actually is I have to remind people not to mime out the answers while they're thinking about it, because you can accidentally cheat off someone else because the person in front of you is going
Oh
number
yeah.
12, number 12. Wait, it's
But they're
no,
not,
wait,
they're not
it's
saying it.
yeah, but their arms can start moving.
That would suck
Number-
if you were on the honor committee and it's like accidentally cheat.
Because the person in front of you
Yeah.
is dancing out the answers.
Like, whoop.
Now, remember, I don't know what this dotted line could be. It could be all sorts of things. I'm just filling in one, kind of a mock thing. It's similar to, well, a cubic function will often give you this shape. Because we talked about the ballerina shape with a cubic. Ballerina means, as you guys face me, to the left is up, to the right is down. The notation is the limit as x goes as far to the right as you can imagine, f of x goes up as high as you can imagine, and as x goes as far to the left as you can imagine, the function goes as far down as you can imagine. Informal definition, really rough illustration, formal notation. Yes?
Why doesn't it begin with the axes? Or the y-axis?
There's no easy way to take a cubic or a 4th degree or 5th degree or 6th degree polynomial and put it into a sort of vertex form. But to go back to quadratics, parabolas, which you can fairly easily put into a vertex form, that's a little bit like asking why aren't all parabolas centered at the origin? There's lots of things going. In a parabola, it's very easy to track what shifts the vertex of a parabola, left, right, up or down, What makes it smile? What makes it frown? What makes it wide? What makes
You
it far?
rhymed.
I feel like I'm writing a children's song about the diversity of parabolas, and how each one is special and should be appreciated. It's much harder to track those things when you get to cubic, fourth, fifth, etc. But basically, these things are all being shifted and bent and warped. It's just we can't simply break it down to A, K, and H.
I thought you wrapped it though as like different sections, and then you can do.
We're going to get to that. That's if you know the zeros. That's when you know where the zeros are.
Right,
Okay.
but we still can't figure out
Hi,
how high or
Junan.
low it goes. It's
Right.
only the intercepts.
Right, and you don't learn that. Stop, Jeanette. And you don't learn that until, without a calculator, you don't learn how to do that until calculus. We'll talk this much about it in May.
Is that why they get the name calculus from calculators? Can do everything that calculus can?
Calculus
No,
was a
because
good idea
calculators
for
couldn't do
calculator.
anything that calculus could for a long time.
What?
The early calculators couldn't do,
Well, now they can.
now they can do a lot of it, yeah. Wolfram Alpha can do almost any of it. Okay, any questions on ballerina form?
The human calculator.
Okay, so remember that this is like a cubic, so y equals 1x cubed is the simplest example of a ballerina. Okay?
You
Now
just
we're
made
back
up.
over here.
You just made up the dotted line, right? That's not really there.
No, that's not really there. It could be
It
anything.
could be different. Okay.
And I have no sense of scale on this. I don't know if this point is 1 unit over or 1,000 units over. But I do know that if it's a positive number and an odd exponent,
It's
at
going
some
like
point
that.
it'll keep going up like this, and at some point it'll keep going down like this.
Do you even know the rate at which
Shoot.
it goes up and down?
Not a clue without more information. If I fill in some numbers, then I'll know all about that. Okay, third case we're going to talk about. F of x equals, again, a sub 1, x to the n, plus a lot of other terms I'm not caring about right now. Again, n has to be greater than or equal to 1 and an integer. But in this case, a sub 1 is negative, and n is even. Your leading number is negative this time, Johannes, and my exponent is even. Here's what's going to happen. I'm going to have my axis here. At some point over here, and I can draw it from the x-axis if I want to indicate that I know the zeros. At some point on this side, over in negative x direction, it's going to keep going down forever. At some point on the right side, it's going to keep going down forever. And in between,
It's feet.
well, in between, it might go like, might just be a parabola. It might have a couple of extra zeros in there.
That was.
Could have all sorts of things. That looks like Humpty Dumpty.
Could there be a sine wave in between?
Egg.
It can look a lot like a sine wave. There's something called a Taylor series where you use a polynomial to approximate a sine wave because it lets you do some advanced math with it, because back in the day that was the easiest way to find the sine of 3.2 radians. You could actually plug it into this polynomial instead and get an approximate value. That's end of...
Back in the
What is
day.
this one called?
This is called a... We actually had a huge debate about this 2 years ago. This one, the name we settled on... See, I liked that it was like a puppet, because the arms are always hanging down.
No.
But technically, puppets don't hang like this.
They hang in.
Well, puppets are just, the hand is up the rear end of the puppet, and it's like that. What is the actual name of the puppets that hang from strings?
Marionette.
Marionettes. So this is
Oh,
the
crap.
marionette.
No.
Yeah, this is not a puppet.
I'm calling it a puppet.
All right, I'll understand what you mean, but this one is the ends of the function hang like a marionette.
How about someone who's flexing?
It's a bodybuilder.
It's Artur.
Well, the problem is that's too easily confused with the cubic functions
Right.
or the parabolic functions.
Oh my
So yeah, the marionette, but this is negative
Wave to
a,
YouTube.
negative a, and even exponent gives you a marionette. The notation is that for this function, the limit as x approaches infinity, as x goes as far to the right as you can imagine, f of x goes down as far as you can imagine, and as x goes as far to the left as you can imagine,
Goes down.
the function also goes down as far as you can imagine. And that's what negative and infinity actually means. Remember, limit is where something is headed. For this course, we don't care if it really gets there or
God. You're
not.
calling it as far as we can imagine. What if
Yeah.
I can imagine more than infinity?
Then you are in good company with George Cantor, who invented transfinite cardinals.
Infinity plus 2.
I am in good company with him, actually.
Any questions on the marionette?
I'm gonna call it the egg.
Okay, I'm guessing
Okay.
that the next shape is gonna be a ballerina doing the other way.
Yes,
Reverse
and
ballerina.
we have
That's
the
an Egyptian.
we have the fancy name if we call it a reverse ballerina. That's all we could think of. So
Wait, why don't we name one an Egyptian? Because Egyptians always
Yeah.
have their right hands up. The ballerinas.
this is the ballerina. Egyptians really do always have their right hands up. So we could call it. Is that true?
No.
He's totally
that's
wrong.
always
He's
what
just
I
making
see.
that up.
From where? Bangles videos? Walk like an Egyptian?
Oh my god.
What is, you're old.
It's a song. I'm ancient. It's an 80s song.
See? You're
Um,
old.
Okay.
I know the song you were talking about.
I'm going to stick with reverse ballerina, but I'll let you go with what you want. N, again, greater than or equal to 1, and an integer. We're only looking at the first term. And
It's gonna be less than 0.
A is
And
less
then-
than 0.
And it's gonna be odd.
N is odd. Alba can spot a pattern so fast. Alright, so for this one, again, I don't know what's going on in between, but at some point it comes down from your upper left, and over here it goes further down to the right. In between, what does it do? Maybe it just has a point of inflection. Maybe it has a couple of loops as well. We don't know. We have no idea what
Maybe
it
it
does.
makes an Egyptian.
Maybe it makes an Egyptian. We honestly don't know at this point. We call this one the reverse
Egyptian.
ballerina. And the actual notation. See if you guys can do this. What is the limit as x approaches negative infinity of this function?
Negative infinity.
No, as we go to the left,
Oh, infinity.
then it's going up.
And then as x approaches infinity, it's downwards.
Yes. The limit as x approaches infinity of the function is downwards as far as we can imagine, so we'll say that's negative infinity. The limit, when you're talking about the limit of a function, you are talking about where the function's y value is headed. So this means, what is y doing as x is doing this?
Mm-hmm.
X is going to the left, y is doing this. So the answer to a limit in all of the questions I'm going to ask you this semester is going to be some sort of y value or up or down direction. Does that make sense? Okay. Couple of quick examples. And all I want you guys to tell me is touchdown, marionette, ballerina, or reverse ballerina.
Really?
Are you ready? Okay. Example. Y equals x squared.
Mom, touch on.
Really? You had to hesitate on that one?
I hesitated too.
Thanks,
Y
Ramsey.
equals negative 5x cubed plus 4x squared minus 3x plus 57.
Ballerina.
Oh, it's a reverse ballerina.
Reverse, what did you look at, Janine?
Well, it's
Odd.
negative 5, so the A is negative, and then N
And
is
it's odd.
And do you care what the other terms are doing?
Nope.
No, there's one exception to this. Here's a great trick question. What if I put x to the 1/2 here?
And it doesn't exist.
Well, then it's not a polynomial, so these rules, you don't know if these rules work or not. So you've got to make sure let me try this again. For n behavior, the only way these matter is there anything here that makes it not a polynomial? But you are correct. That is reverse ballerina. Okay. Like the red better, I decided. Y equals negative 27x to the 52nd power.
That
That's
is,
a
guy doing like.
Marionette.
Marionette. I wish the camera could see you guys on this one.
Why?
They're quite entertaining.
The interpretive dance.
Yes. And here, I'll give you an easy one on the last one. Y equals x cubed.
Ballerina.
Ballerina.
Ballerina. What if I make this y equals x cubed plus 500,000 x squared?
Ballerina.
Still a ballerina. It's going to be a very different shape of a function, but it's still a ballerina. I know it will look like this at its end behavior. This will very much change where that end behavior
And
begins.
spread out.
Yeah, that's going to be a weird one actually. It's going to have one giant loop, I think. That should get you through what I wanted you to get through.
Ow.
Did I hurt your brain? I'm sorry.
No, I.
It's okay, Janelle.
Never.
Wait, are you telling us the homework now? Or?
Page 312,
We start from-
2 through 24, even.
Every other even.
Sure, stop.
Yeah.
Say bye.
Bye.